All right, so we're going to be talking about angles today, and we're going to be talking about angles not inside geometric shapes. I know usually we talk about angles within triangles or maybe even a circle or a pentagon, but we're going to talk about angles today in the idea of rotations, meaning as I'm rotating around a circle or in a circular motion. Some of you may not know this, but my favorite skateboarding game was Tony Hawk when I was growing up with the original PlayStation. Pretty cool. And the one thing I always remember about that game is that I was pretty bad at it, but if I hit the buttons in a certain way, right, like I'm just kind of button mashing, I would do like an 1080 McNally McTwist super backflip combo or whatever. I don't even know what it's called. But the point is that the skateboarder would do 3 backflips, meaning he went 360 degrees 3 times, which is 1080. So we're going to investigate angles that may have more than one rotation, and how would you graph such an angle? So we'll start it off easy here, kind of explain. So we have 7 pi over 6. Now, how would you make this angle into degrees? Because normally, I know students are more comfortable with degrees. As you continue on in your mathematical careers, radians will become increasingly more important. But for this exercise, we'll go ahead and change it into degrees, okay? And I'll show you a little shortcut here, and then we can do it quickly. But the ratio, or the proportion you need, or the ratio, excuse me, that you need to change it from radians to degrees is multiplying it by 180 over pi. What that does is, it gets rid of pi, because you can cross those out. Then you can cross-reduce with 6 and 180. 6 goes into 180 30 times. And then 7 times 30 equals 210 degrees. So, now we have to graph 210 degrees, meaning we have to decide how far along the circle, or the rotation, is 210 degrees. So I start by drawing a Cartesian plane. And I always start on the positive x-axis. So that's where I always start. I will start there on the positive x-axis. Another important thing to know when you're graphing these angles is which quadrant will it terminate in? Meaning, when it's done rotating, which quadrant will I end up in? So just to make sure we're all on the same page, quadrant 1 is in the top right, quadrant 2 is in the top left, 3 in the bottom left, and 4 is in the bottom right, okay? And it's also helpful to know the quadrants because we can use this to help explain which direction we rotate, because we could go clockwise, which is like this, right? Clockwise is like that. Or I can go counterclockwise, which is like this. And a lot of students get confused on which direction you turn when you have a positive or negative angle. So here's the way I like to think about it. If it's positive, we go in the direction of the quadrants. Meaning, if it's positive, I go 1, 2, 3, 4. Okay? If it was negative, or the opposite, I'd go backwards. 4, 3, 2, 1. So this happens to be positive 210. So I'm going to actually go in the order of the quadrants 1, 2, 3, 4, which is known as counterclockwise, meaning I'm going backwards of a clock. But here's another way to think about it. If it's positive 210 and I'm going counterclockwise, that means I'm turning back time, meaning I'm gaining time. I'm getting more time back. Ooh. Or if it's a negative angle, I'm actually losing time, right? Because time's going faster because I'm going clockwise. So this is the way to think about it. So for 210 degrees, I know that I need to go at least 90 degrees, right? And every quadrant has 90 degrees in it, because 4 quadrants all the way around, a full rotation is 360. So I know for me I need to go, that's 180 right there. So from 0, and I had 2 quadrants, that's 180. And 210, just a little bit farther. So that's 210 degrees. Okay? So that's kind of an intro, like how we graph angles inside of a coordinate plane or Cartesian plane, and changing it from radians to degrees, and then kind of going over the quadrants. So this would actually end up in quadrant 3, and that is how we graph these angles in our Cartesian plane.